All right. So once again, my name is Jeremy. I'm one of the naturalists at the Squam Lakes Natural Science Center for those names that are unfamiliar out there. And tonight we have a really interesting presentation that I've been waiting for. I'm glad I got to host this one about brook trout here. So we're going to hear from John Magee, and I'll highlight his video in just a couple of seconds. But he is from the New Hampshire Fish and Game, and he's the Fisheries Habitat Research and Management Programs Coordinator, here to talk to us about brook trout and climate change. And I will turn it over to him.
All right, and I'm going to share my screen. And bear with me just for a second. There we go. Okay. Thank you, Jeremy, and welcome everyone. Happy to have you here, and hopefully we'll get some good questions. And even if you don't have questions, it's okay. I hope you enjoy what I'm going to present tonight. I was asked to present exactly what you see as the title here now. Basically, some things about our wild brook trout and how climate change is impacting them now, predicted to impact them in the future, in fact, the near future, and some things that we can do about it. Oh, and I should say at the end of the presentation, I also have my contact information. So if you want to get in touch with me for anything, questions, I always make a pitch to tell people, if you'd like to volunteer with the department, if you'd like to come out electrofishing with us, I'll show you that in a minute. We take, we love it when we have volunteers come out to do that with us every year. So our subject tonight, wild brook trout, and I want to distinguish them from any brook trout that we raise in our hatcheries and stock into the waters and streams. So the wild ones are just that, the wild ones that are out in the streams, rivers, couple lakes and ponds. They are officially our state fish. By law, they are our state fish. We have a number of state animals and insects or animals and insects and things. Wild brook trout are our state fish, and for good reasons. I mean, if you just look at this picture taken by my colleague, and actually my two supervisors above me now, Diane Timmons, who used to be in the northern part of the state as our cold water, our trout biologist. She's now our division chief and doing a great job, in my opinion. And this is a picture she took from a fish that she caught and others caught in Pittsburgh. Excuse me. And it's just a pretty thing. It was in late August, and I always put this one on here. So they're pretty. People like to fish for them and catch them. And they also are, as I will talk in a little bit, they also are a species that really needs clean, unpolluted, healthy habitats. And they're particularly sensitive to pollution and alterations. This slide I'm going to show towards the end, but mostly I just wanted you to, and since this is being recorded too, then folks can always go back to this, but some key messages I do want you to hear. I'm going to talk a lot about summer water temperatures, because they are the thing that really determines where brook trout can and cannot live. I'll get into that in a little bit. And then this thing about dams, which increase water temperatures downstream, and also culverts under the roads can be barriers to the movement of these animals. And just an easy thing to remember, barriers are bad. Barriers are bad. Some of the things we can do, again, I'll talk about this later, protect those stream side, those riparian areas. Not just stream side, of course, lake side as well, riparian areas. Remove those barriers, conserve land, and overall reduce our impact on the land and climate with each of our individual and collective, or I should say our individual decisions that we make every day. So I want to walk you through where we have wild brook trout in New Hampshire right now. A way, or really the way we determine that, is we have to go out and collect data, right? The way that we catch any kind of fish in streams that are shallow enough to wade, like these four people are here, is we use something called electrofishing. And in this case, if you're wading, it's backpack electrofishing. Jeremy, could you just tell me, can you see my cursor right now?
I can, yes.
Okay, thank you. I should have asked you earlier. So this gentleman here and this gentleman here too, they're wearing different types, but on their backs, they have this backpack with all kinds of electronic stuff that I don't know how it works. And he has this pole here that has an insulated tube and a metal ring at the end. And you can't really see it, but on his hand right here at his thumb, he has a little switch. You can turn on the electricity. Electrofishing is literally using electricity to stun fish. You can do this in lakes and ponds, but in this case, in streams and rivers. And then with a net, a dip net, you quickly catch those fish and then put them, say, in this bucket here that this young man is holding. I get this question all the time. The humans are not supposed to get shocked by this because we're wearing waders, as you can see these 4 are, and also protective gloves. These are actually the same types of gloves that people wear when they're working on the electrical lines, up in the air, the power lines. So they're very good at insulating. And then what we can do with once we have those fish in the bucket, you do your standard survey and length of survey, which is generally 100 meters, 325 feet or something. And then we measure and weigh, we identify all the species that we catch. And with all those data, you can do all kinds of really great things with. I'm going to summarize some of that. But that's how we go out and collect the fish. So right now, brook trout, and this is going to be a theme of a couple maps I'm going to show you. Generally, they're not in the southeast. For the most part, they're in elevations greater than 600 feet, but not everywhere. Some places lower than that. And they tend to be in smaller streams, but the farther north you go, the more likely you're going to find them in much larger streams. So if you follow my cursor over top of the map, all of the brown, the light colored dots are places that we've done this electrofishing and not found wild brook trout. And you can kind of, if you just look quickly at this, you can kind of see those lighter dots. They're all over the state, but they're really concentrated in the southeastern portion of the state. The streams and rivers in the southeastern part of New Hampshire generally are pretty warm. There are some blue dots, the dark dots, where we do have wild brook trout, which is kind of neat. They're all in small streams in the southeast. But conversely, and this is something I'm gonna kind of sort of draw a line with the mouse here a couple times on a few different maps. The species is generally from about where I am here. This is, I should know this, near Ossipee, kind of diagonally southwest to the Warner River watershed, and then sort of down along the higher elevation of Western New Hampshire and north. So the White Mountains, northern New Hampshire, that's where this species lives. And this is where I start talking about water temperature a lot. So we, to understand how the summertime, because that's the key time of year, the summertime water temperatures affect brook trout, we have to go out and collect data. And if you just go out and measure the water temperature when you go out to do an electrofishing survey, or if you happen to be near the stream, that's not enough data to really understand, is this stream suitable for brook trout, or is it not suitable, or is it suitable but maybe not so good? So we routinely, and this is just one model, put out these little water temperature data loggers. You can see they're about 5 inches long and maybe an inch in diameter, a little more than that. We put them in a protective case. We cable them with strong cable to cinder blocks or to small boulders and streams, and to keep them protected. We also try to hide them, because when people find these things out in the streams, every time it seems like people will pull these right out of the water. And so if you take all the data from the summertime, June through September, and you look at just the average, that's what mean means, the average July water temperature, you can then start to figure out where are the cold areas, the cold streams in the state, and where are the warmer ones. And so what I want you to focus on is these larger circles, the dark circles, the dark blue and dark green. They tend to really be focused. What's the right word? Concentrated, or they tend to be from about that same kind of line, sort of near Ossipee, kind of going diagonally, Warner River watershed. And so everything west, not everything, a lot of sites, a lot of streams west and north of that are where those colder temperatures are. And so that's the same thing that we saw where the trout, well, they're where these colder temperatures are. And at the farther north you go, and in the White Mountains, higher elevations, you have more of these, what I've called super cold. That's my technical term for the day. Super cold streams. These are kind of streams, if you were to put your feet on a warm summer July day into a stream that's 10, 11 degrees, and I should say this is Celsius, so 10 is about 50 Fahrenheit. This feels really cold. In the first 30 seconds, it feels nice. And then after that, you start to feel, your feet don't feel so happy anymore, even if it's 80, 85 degrees outside. I'm going to show you some graphs in just a moment here. Let me go back. In this area, Nash Stream Forest, where we've done a lot of surveys and a lot of research. I've spent a lot of time up there. And then a little bit later, I'm going to show you some data from down here in Manchester, Bedford. There's a neat little wild brook trout stream. And that's relative to dams and removing dams and how that affects trout. But first, let's just, in terms of climate change, let's look at Nash Stream. Oh, I forgot. So to tie those two things together, we're talking about that July water temperature. If you plot, and these are sites where we have both electrofishing data and water temperature data at the exact same site on a stream. And here's our average water, July, in this case, water temperatures. Okay, you can just point this out more in a second, but here's 20, that's 68 Fahrenheit. And you look, and if you plot the density of trout, in this case, I have both adults, the squares, and then babies. So those are like 3-inch trout and smaller, born that year of the survey. What you find is at these colder temperatures, there's, that's where the trout are. They're in those colder temperatures. But once you hit about 20 degrees Celsius, 68 Fahrenheit, and again, this is the average temperature from those data loggers, which I forgot to mention, we set them to record every hour on the hour. So over 31 days of July, 24 measurements each day, you calculate the average for that value. If it's above 68 Fahrenheit, the predictions and the data show that we only have 3, sort of 4, but I'm going to call it 3 streams where we have wild brook trout populations above that. So that's how dependent this species is. They need that clean, cold water. Just as an interesting kind of thing, I think these 3 streams are all right next to each other. They're all in the town of Warner. They all flow off the same general hillside. 2 of them flow right under Route 89. One of them flows almost under Route 89 in the southern part of Warner. And for some reason, those 3 streams, the trout are existing at warmer temperatures than anywhere else in the state. This is a couple hundred sites here. For some reason, those populations, maybe a unique genetic lineage, we're not sure. Oh, so where are they the strongest? So we know where they are. We know where the water is the coldest. Does that actually translate, or does that mean that's the strongholds, if you will, of wild brook trout in the state? That same theme I keep saying from Ossipee, it's probably a different town, but somewhere near there, kind of going across the state this way. Concord is right down here. So a little north of Concord and down, that's where the darker green circles, which are the ones with the highest biomass. Biomass in this case is when we do our survey, if you weigh all the brook trout together, it's the total weight of all the trout we caught divided by the surface area that we electrofish. And these values don't mean a whole lot to anyone. If you see 16, what does that mean? Well, basically 16 and higher is a really healthy, pretty densely populated brook trout stream. And again, the same thing. They're sort of like Warner River watershed in north, with a couple darker or a couple higher populations, in various places, some of these little streams in various areas. All of those little streams in southeastern New Hampshire where they're doing really well, they all tend to be small streams. They all have a lot of groundwater going into the stream. But there's some places, it's just highlighting these, there's 6 or 7 places here, 6, where we just don't have a lot of sites. In Lincoln, in this part of Lincoln, we have 1. This is the Pemigewasset Wilderness. Just to give you, just throwing it out there. So what you can do when you have all of this water temperature data and you have all of these fish survey sites data in New Hampshire, we have it's 4,500 or 5,000 sites we've done electrofishing like that, which is great for a little state. If you have all those data, you can start to do things with them and make predictions. And so relative to climate change, this is something that folks at UMass Amherst and the U.S. Geological Survey and other people, I'm forgetting who else, so my apologies to everyone that I haven't given credit to. I'm going to show you 4 slides here, and these are current conditions. Hopefully you can see the whole words right now. It's sort of off the screen on mine right now. But the big thing to look at is these lighter colors are better. It means that the temperatures are good and the predicted occupancy, how much of the watershed on this little bar here, how much of the watershed is probably occupied by brook trout right now. And you can see green and yellow is, 75% or more of the water of these watersheds. So this is sort of the Berkshires in Western Massachusetts through Vermont, northern New Hampshire here, into Maine. Maine's very yellow, very bright. And I think this is I should know this, the Catskills down here, or am I too far away from the Catskills? Oh yeah, not sure what that is. This is the Catskills, this is the Adirondacks. That's right now. Now you can use this to model what if the air temperatures were 2 degrees higher. And 2 degrees, and I should say this is 2 degrees Celsius, which is about 4 degrees Fahrenheit. 2 degrees Celsius higher. So this is one of the climate change predictions. Oh, by the end of the century, we might be at 2 degrees higher air temperature. Using all those data, you can model where these fish are. So the next 2 slides I'm going to go through pretty quickly because of the same thing, except that they're at 4 and 6. So let's go back. This is right now, lots of yellow, that's good. And in fact, these models are really accurate. Where it's yellow, that yellow is correct. If we, with climate change, if the temperature in the summer goes up 2 degrees Celsius, you can see there's a lot more dark watersheds, much fewer brook trout. If you go to 4 degrees, that's fewer. And then by the time you get to 6, which is one of the higher predictions for climate change scenarios by the end of 2100, I think, you only have this one in northwestern Maine. It's a big watershed, but in northeastern New Hampshire, Dead Diamond watershed, Rangeley area, I think, of Maine, that still has a solid brook trout stronghold. Interestingly, the White Mountains no longer is as stronghold as you would want it to be. So those are predictions. Have we actually seen something like this happening? And have we seen brook trout populations diminishing because of this? Answer is yes and no. And partly that's because, and I'll show you some data from the last 16 years, water temperature data we've collected. In terms of water temperature, some other things, at least what we've collected, Fish and Game, we have like 16 years of record from 2 watersheds. There are other data available. I didn't go into them for this presentation because I think our data set is pretty enlightening. So I'd mentioned earlier Nash Stream north of Lancaster in northern New Hampshire. It's where we've done a lot of research. We have deployed those water temperature loggers every summer since 2005. In fact, since 2010, I think it is, we've had them in the water every day of the year. And this is just the summer. This is actually July and August temperature, but the average summer temperature, I'm calling it, by year. So this is 2005, and over here on the right's 2021. And if you just draw a simple trend line without a lot of data analysis, it shows that it looks like the summertime water temperatures, even in northern New Hampshire, have increased about 1 degree Celsius. Now that's 1 degree Celsius. 1 degree Celsius doesn't sound like a lot, except, and I'm just going to go back to my graph here. This is, and I should have said this is from our data, but if you're at 19, if you're a stream, you're a brook trout living in a stream at 19, and you're doing okay, your population is doing okay. If you get pushed to 20 or worse, 20 and a half, 20 or 21, most likely you're down here at 0 density. In other words, it's not suitable habitat anymore. So that's number one. Number two, if you go up 2 or 3 degrees and you used to be at 16 and now you're at 19, well, this trend line means that on average, you're going to have maybe only half the trout there. So the population's been quite diminished, even though it's still there. So let me go back to where we were. So this is Nash Stream. This is a medium-sized river right now today, or well, let's say during the summer at low flow, where this data is from, it's 40 feet wide, something like that. You can walk across it if you're careful. It's not a raging river in the middle of the summer usually. And this is right near Slide Brook. So the next one I'm going to show you is actually in Slide Brook, which is a very small tributary. It's a couple feet wide. It's very steep. It has brook trout in it, which is remarkable because it is so steep. And a data set over a similar time period, we also see a little bit of an increase in the temperature. But for here, for the purposes of the presentation, I said it was a small, or at least a smaller increase. It isn't really gone up a whole degree Celsius. It's around half a degree Celsius. But what was interesting is that also in Johnson Brook, another small cold, in fact, even colder, this is one of the colder streams we have in our data set. And we've been doing research on this population of brook trout here since 2007. We also see almost a degree. So it's a little bit of mixed bag, yes and no. Have there been some changes? It almost looks like, and I'm not showing you our data from the Dead Diamond River watershed, which is just to the east of this, but it showed a similar pattern. The main stem rivers seem to be warming up over the last 15 years, more so than the colder tributaries. And so I'm not going to talk about culverts too much tonight. We could do a whole day of workshop on them pretty easily and have. But here, if you see this one here, so there's a stream going under a road here, and it's got this perched, not as in perch the fish, but just perched up higher than the stream bed, and it makes this waterfall. And so it's bad because it's a barrier. This is, I think, 4 feet high, and brook trout can't jump that 4-foot waterfall. So that's a big deal because brook trout are a species that like to spawn, in fact, need to have healthy populations, need to spawn in certain areas. A lot of that in watersheds or in these small streams. That's where the babies are. A friend of mine, Dr. Barry Wicklow, who's retired from St. Anselm's a few years ago, he likes to call them spawning factories. I mean, they are. That's where in the watershed, a very large proportion of the baby trout are born in the smaller streams. They could happen in a larger stream like the main stem of Nash Stream, and it does, but those smaller tributaries are really important. So if there's a barrier in the way, in the summertime or in September, October, when the trout are moving upstream to spawn, that's when they spawn in the fall. If they can't get up through there, that's a big deal. So one thing to think about, let's say, trying to come up with the right analogy, a little different though. Let's say it's really cold out and you need to get into your house and you can't find the key to your house. You lost the keys, you don't have any hidden outside or whatever. But you really need to get out of the cold. It's 20 below, it's windy, and you can't do it. It's sort of like you have that barrier. You can't get into your house to protect yourself. That's obviously bad. Well, it's sort of the same thing, except the opposite way with warm water with trout. If they're trying to get out of main stem river that's getting a little warm, maybe it's suitable for them, but they want to be in colder water. This happens every year in these places. They'll move into the smaller, colder tributaries, but if they can't do it, they can't get into that area to get us to a safe place. Even if it doesn't kill them right then, over time, over years, that has a pretty big negative impact and diminishes those populations. I'm not going to talk about this much, but also a lot of culverts around pipes, even the concrete box culverts, can be very undersized to streams. Not so much now. We've all learned so much more about what size they need to be for a particular stream and stuff. So we're better at doing that. But we have a lot in the state, 20,000 stream crossings in the state. A lot of them are really undersized. And during high flows, even summer storms, which we are getting more frequently, these things can't handle that amount of water. They can't handle the sticks and leaves and rocks and things that are flowing down the stream naturally. And so some of them get plugged up. And so I'm not going to go into this tonight, but there's so many times in just little New Hampshire, and especially with Tropical Storm Irene for Vermont, where that just caused just terrible things for humans, and also, of course, the streams and the trout in them. And I just have here's a bridge. It's designed to handle these high flows. It's got a natural stream bottom. Fish can swim through here. This is actually Slide Brook, which I showed the graph for earlier. So I wanted to show you some things about dams. And I'm not here to berate dams tonight, but I just wanted to make sure that you understand that they can have impacts. And there's an active restoration group, a lot of my colleagues, including myself, where we remove dams in a prioritized manner. Usually it's dams that serve no purpose anymore. This one happens to be Terrell Pond in Pittsburgh, New Hampshire. It's almost on the Quebec border. The west branch of Indian Stream is actually flowing from right to left. Here's the dam going downstream. If you were standing looking at the dam and then you just kind of walked a little closer to the water and turned right a little bit, this is what you'd see looking up the pond. It's a shallow, a shallow pond. So what happens here is that it is this dam, Fish and Game owns it. This dam is creating this very shallow pond upstream. And the water temperatures that are coming out of this dam are really hot. So I'm going to show you some, Terrell Pond, Pittsburgh. So this is where it is. This is just a Google Earth image, just a aerial photograph. I put the dam here as a little volcano to emphasize that it makes the water hot. So this stream, the west branch, comes down. It's actually a little this way. But if you measure the water temperature upstream, it's very cold. In fact, it might even be that super cold range that I was talking about earlier. Great for brook trout, lots of trout. Excuse me, it goes down into the impoundment. And when it comes out at this point right here, downstream of the dam, it's too hot for trout. It flows down more, another half a mile. It's still too hot for trout. And in fact, our fish surveys, we don't catch brook trout in these places. So the dam has made it too hot for this almost 3/4 mile of stream. And then when the middle branch, which is on the right here, which is cool, comes down and they come together, that coolness of the middle branch does help cool down the main stem of Indian Stream. But even here, I put it in, I didn't want to bore you with too many numbers here, but it's almost too hot for trout. And that's really too bad, because if you zoom out and you look at Indian Stream farther downstream, another 2 miles downstream, it's still almost too hot for trout. There's not a lot of brook trout there. They're there, but they're not, it's on the edge of being too warm for them. And then even another 3 miles or more downstream, the main stem of Indian Stream is still almost too hot for trout. And the point I wanted to show you here is just this one little dam on one little tributary heats up miles of Indian Stream, which would otherwise be a really nice brook trout stream. So if you were to remove that, and I'm not showing you the numbers and the predictive models I use, but if you were to remove it it would push this still almost too hot for trout right down into this cool rating. And actually right here, it'd probably be very cold still, but it would be much more suitable. We'd have a lot more trout in there. This was kind of a neat success story. What happens when you actually remove a dam? This is this one in Manchester and a little bit of Bedford. If you look across years on the bottom here, in 2011 through 2016, we had my colleague and our coworker, Ben Nugent, was the one that did this work, collected water temperature data. And this is just the average summer temperature here on the left. And the stream is on the warm side. It doesn't hit that, magic 20 degrees Celsius, but the New Hampshire Rivers Council and others removed 4 dams. I think at the end of 2016, might have been early 2017, but those average summer temperatures, instead of being up near 17 and a half or so, now they're down at 15 and a half. 2 degrees doesn't sound like a lot, but to a trout, 2 degrees could be between life and death for them. And certainly, and I don't show this here, but the trout populations have also gotten better in the last couple of years because of this. So remove the dam, you decrease those summer temps, make it more suitable. And again, not to berate dams, but just to show the science and the data that in some cases, some of these small impoundments really do heat up the water temperatures downstream. I'm guessing all of you already have seen this graph or know all about ice out on Lake Winnipesaukee. I'm not going to talk much about this, but on the left side is, from the 12th of March to the 21st of May. In fact, I think the latest was like the 13th of May or something like that. But this is when ice out is officially declared. And if you just draw a trend line, the computer did this for me, not me hand drawing it. You start to see that, since about 1890s, I think this is 1887 to 2021, there's been a slow decrease. So I can't remember how many days people usually say about it, but if you look at it, it's a week or 2 that the ice is going out earlier. Now that may not seem like a big difference, but there are fish like rainbow smelt in Winnipesaukee that spawn as soon as the ice is out. And so if the ice is going out a week, 2 weeks, 4 weeks on average earlier, that could have potential implications for those fish. I have just a couple more slides. I wanted to talk about riparian corridors. Again, I'm sort of guessing that you might already know a lot about this, but the stream side or lakeside vegetation. And namely 2 things. Number one, when it comes to water temperatures and climate change, shade is really important because there's 2 things that are generally what warm up streams and rivers. And that's the amount of sunlight that's hitting it directly, and also the air temperature. So you can't change the air temperature much, but if you wanted, you could go down and cut a bunch of trees and the sun would hit the stream more, warm it up. And there are instances and situations where that has led directly to like a trout population going away from that stream. So super important that these are here just for shade, but not just for that. In streams and rivers, this is true for lakes and ponds too, but in terms of brook trout, more wood and pools, which are often formed by big trees, down dead logs and things in the stream, mean more. I should have written this too, more and bigger brook trout. So what happens if you look upstream, it's hard to see, but it's a little shallow water. Any trout that are in here are the little trout. So no adults that are going to make babies for the following years. But this is where a lot of the bigger trout are hanging out, or in these big deep pools where they got places to hide amongst the the wood that's in the stream. And that wood doesn't come from 500 feet away from the stream. It comes usually from, within 20, 30 feet of the streams and rivers. So that's where the trout are hanging out. I just took a whole bunch of data and made this one slide and one graphic. Trout love wood. They also tend to be clustered around that, which makes sense. It's not just that the wood is making pools. They also use it to hide in. And then I don't know if any of you have ever known my friend and colleague, Jim McCartney, who used to work for Trout Unlimited. Now he works for the National Park Service. He too is kind of hidden in the wood here, as you can see. But trout, the big point is they love those deeper pools. They love those places to hide. This has a lot of relevance, this slide, to not just streams and rivers, but to lakes and ponds downstream of them, and the importance of those riparian areas. So what I want to show you is, even though this is a small stream, it's one of our research streams, Emerson Brook, we did some in-stream wood restoration. We literally cut trees away from the stream and just carried them in. These are small. It's hard to even tell how big they are. They're only about 3 to 4 inches in diameter branches. You put them in the stream and you can see all these leaves that are collecting. This was in November, 10 years ago now, I realize. And these are real hot spots for biology that's going on in streams and rivers. What's happening here is there's all these microbes. There's bacteria, there's fungi, and they live amongst these leaves and these sticks and branches. And they're not eating the leaves and sticks and branches. They're just taking up nitrogen, phosphate, and nitrogen in various forms, and phosphate from the water. And these streams and rivers, mountain streams and rivers don't have much of these. But these microbes are very effective at taking every little bit out that they can. In fact, if they just go downstream a couple, like 20, 30 feet, you can actually find a measurable decrease in the phosphate just because of the microbial activity. So there, of course, there's insects like the stonefly. That's a shredder insect. In other words, that's how it eats. It shreds up the leaves, and it's not really getting much nutrition from the leaves. It's getting nutrition from those microbes that are on the leaves. And then, of course, there's fish and things like mink and heron and other animals and people that might eat the fish. So a big point here, though, regardless of the insects and the fish, is that a lot of this nitrogen and phosphate is being taken up by these microbes and not going downstream. And especially if you're concerned about our lakes, that's an important thing. Keep those riparian streamside areas healthy, let wood fall in on its own, do some restoration. Belknap County Conservation District, for example, is doing this around the Lakes region now. And they've been great to work with. And a lot of what they're doing is for trout habitat and also to reduce those nutrient loads going downstream into Winnie, Squam, some of the other lakes. So again, I'm not going to repeat all these, but it's those summer water temperatures that there's other things too, but for the purposes of this presentation, I wanted to focus on that. Dams can increase that. Barriers are bad because now they can't get into the colder water. What can we do? Protect those riparian areas, which I should have mentioned earlier. If we stay out of the footprint of streams and rivers, then we're also not being harmed by them when there's floods, because there will be floods. And we know with climate change, those floods are going to be more frequent and more higher stream flows, and so potentially more damaging. Thus, even more important why we stay out of them. Remove those barriers. There's all kinds of people removing dams and replacing culverts with bigger ones or bridges. Land conservation. I know I'm just putting this on here really quickly. Land conservation is such a huge part of this because, as you might know, the White Mountain National Forest was started to try for one reason, to try to reduce the amount of flooding downstream. So that's made a big difference. I think that, is it the Catskills? I should remember this, that New York City owns or has conserved a lot of land upstream to make sure that they have drinking water supply. And then, without going into lots of details, reduce our own impact on the land and climate. That could be from the driving decisions you make, just how we live on the land. Every presentation I do, I always put a wood turtle in it. I'm not a wood turtle biologist, but I love them. They happen to live in brook trout streams a lot of times. So I think that's the end of my presentation, and I'd be happy to take any questions. I think I will stop sharing so I can see folks.
Great. And yeah, thanks, John. That was great. And we'd love to take some questions. Anybody that has questions, feel free to, we'll try to have you unmute yourself and see how that goes. If you don't want to do that, you can write it in the chat and I can relay that to John as well, just so he doesn't have to keep track of that. I know he can read it, but I'll track it. So feel free to jump in and ask a couple questions. I have a couple myself.
John, I do have a question. Can you hear me?
Yes, I can. I'm just going to my screen here so that you guys can see it in case you need to write down my contact information.
Okay, well, my question relates to a point you made earlier about the ponds, and downstream from the ponds, the streams will be warmer and therefore brook trout will have a problem. As beaver have increased their spread across New Hampshire and elsewhere, obviously they're creating ponds. And although many points are made about the positive impact of beaver dams and the ponds that they create, this seems to imply that at least in terms of brook trout, they would have a negative impact, at least downstream for a distance from wherever they erect their dam, because the water would warm up. Yes?
Yes and no. The neat thing about biology is there's so much complexity, although that can be a little frustrating too. I think it's very site specific. So I'll give you an example. You can't see it, but just that way, 1,000 feet, 1,500 feet, our neighbors have a little stream that goes through their large property, and then it goes down another 1,000 feet or less from us on that side of me. And there are brook trout in that stream. And when the neighbors over there, when they did some forestry, it actually led to beavers coming in about 5 to 10 years later. And they made all these beaver ponds, which are great wildlife habitats for all kinds of animals. But just like you said, my guess is, I haven't been doing research on that stream. My guess is that stream warmed up because of it. It's a very small stream. I mean, these beavers literally are putting their dams in the first couple 100 feet of those streams. I mean, that's how small the watershed is there and how small the streams are. I'm sure that had a negative impact on the trout because now they're warmer. But conversely, some places I've been doing research at, say, Nash Stream Forest in northern New Hampshire, there's places where there's beaver dams there, and we've measured water temperature downstream, and it's still really cold. Those streams tend to be colder. Number one, they tend to have a higher base flow. So at summertime low flow, there's just more groundwater and it's colder. So it's very site specific as to what the immediate effect of a beaver dam and a beaver pond will have on a trout population. In the longer term, one of the things, or I should say in the sort of medium term, what often happens when a beaver dam and pond is created is the trout in the pond actually do really great for about 5 to maybe 10 years. They grow faster because there's all these nutrients, there's all these little insects in there. They're able to get away from predators better because the water's deeper and it's a lot more open. So if you're a mink trying to eat a trout and you kind of look around you and there's like 100 feet of open water, it's really hard to corner the trout and they just take off. But what happens over time with a buildup of organic matter is there's also less oxygen in the water, and so the trout don't do as well. But the evolution of beaver ponds is that they're there for a while and then they go away for a while. So generally, beavers and trout do very well together. They just don't always do super well together at the same exact time. I hope that answers your question.
Yes. Yeah. Interesting.
Yeah.
Thank you.
And he kind of stole one of my questions too. Thanks, Tom. No, it's a good thing. Linda asked in the chat, what is the heavy metal load? I'm assuming in the fish or in the streams.
Oh, well, I'm going to take a little bit of a guess of what she's asking about. Across the whole Northeast, we do have mercury problems with all of our aquatic biota. So I don't think I'll go into all the details of that, but that's specific to that metal, to mercury. which is a naturally occurring element, but we've also put a lot of it in our atmosphere through the burning of fossil fuels. So we have an unnaturally high level of it in our waters. And what ends up happening through some unfortunately neat chemistry is it tends to accumulate in fish and things that eat fish. So there are some, if that's what your question, Linda, was about, there are some there is a general fish consumption warning for the entire state. I think these are, if not exactly the same, they're very similar across all the northeastern states. That basically, for the most part, it says if you're pregnant or could become pregnant, you should limit how much freshwater fish you eat. And I forget the exact numbers now. But for most people, it's just generally no problem. But that said, if you want to learn more about it, you can do a quick Google search or something online. And there's some information you should be able to readily find on that about the advisories.
Great. We can jump in with another question from the chat here. How large do brook trout grow in the types of streams you've been talking about?
Great. I would say, I should know this because I was just playing with the brook trout data this week. Our biggest trout in general are wild brook trout are 10 inches or smaller. But I will note that is a broad generalization. We have caught at Nash Stream, we've caught 11 and almost 12-inch trout just a year or so after we did some restoration work. Excuse me. I caught a 12-inch wild trout in Stoddard once. So you do see them, and I do a lot less of the fish surveys than, I do fewer fish surveys than my coworkers do, but in general, 10 inches or smaller. But there's some places that, we have 14 and 16-inch ones too.
Great. Allison says, we live near a trout stream and it flows under a trout stream, or the bridge, must be a bridge. The bridge is scheduled to be replaced. I see. Is there anything that should be done to preserve the trout population? What effect would redoing a bridge have on the trout population?
So bridges, so the photos that I show right now, the photo on the right is actually through a culvert. This is a 21 foot wide culvert, Long Mountain Brook in New Hampshire, in northern New Hampshire. And you can see the stream that inside that culvert. That culvert actually has a bottom, an aluminum bottom on it, but you can't see it because we designed it and we constructed that stream bed with certain size rocks and everything to mimic the natural stream bed.
So that short-term disruption in the long run is probably better.
Well, the culvert that was there before was awful. The thing, I mean, it was not getting washed out, but it was diverting the stream every couple years down the road. That's bad. Roads are bad. I mean, streams are bad for roads when they're flowing down them. But it was also perched, there was a waterfall coming off the downstream end. So when it comes to, the reason I mentioned the culvert is it's a little trickier to make sure that a culvert is pretty invisible to the stream. It's not impacting the stream. It's not impacting the fish that are trying to swim through there. That culvert on the photo on the right, it looks like a natural stream flowing through there. And so the fish, the trout, the dace, the sculpins, they just go right through that. With a bridge, that's generally true too. When I work with Department of Transportation, especially that department, but also towns sometimes, when they have to reconstruct or do work on bridges, there's a very, what's the right word? Sometimes long, but a very careful planning and permitting process that goes on to ensure that if there are any impacts, especially when we redo bridges or, put big boulders around the the piers of bridges or the abutments of bridges to protect them from high flows. Excuse me. There's a whole planning process and permitting process to really ensure that those impacts are really short, like just during a week of construction or something like that. I would never say it's perfect, but when I first got to Fish and Game, I was told by one of my coworkers, we don't work with DOT. We don't like them. We don't get along. And that prompted me to get along with them. And it was really easy because the people at Department of Transportation are really good people, just like anyone else, and they want to do good work. And we've had so much success over the years of working with them and others to make sure that any impacts during construction are as absolutely minimized as possible. And I would mention Department of Environmental Service has been wonderful about that too. We're all partners on these things.
Great. We have a couple questions on stocking. Is there still stocking in some remote ponds by helicopter?
Yes, there is. If you go on YouTube, I bet you'll find some videos, because we do have some folks that are try to guess when the helicopter is going to be at a pond, and they'll go up to the pond and get video of the helicopter coming in. In fact, actually, I think on Fish and Game's YouTube channel, we have one. I'm trying to remember if it's a piece of a Northwoods Law episode that shows that in action and how they do it. And I'm trying to remember. Hopefully, I got this right. I think we might stock 44 ponds like that. I think it's 44.
Nice. And then from that was Betsy. Jim asks, what effect does stocking have on native trout?
How much time do you have, Jim? Because we could talk about this all night. The short answer, I'll try to make this concise. If you have a field of cows out and those cows depend on the grass in the field, they get all their food from that. And I don't know, say you have 10 cows in the field and that's sustainable. And then you put 20 more cows in the field. You can imagine that's not going to be a good outcome. So, the stocked fish will compete with the wild fish, the wild trout, I should say. The other thing is, we're getting, we have concerns about, this isn't a good analogy with the cows, but if you had wild cow, let's say you have deer, and then you put very, what's the right word? Not inbred, but deer that weren't really well suited for the wild, just like our stocked fish generally are not very well suited in the wild setting. You could have them breeding together, or in the case of fish, spawning together. And so, there's the concern, which we share, but I know a lot of anglers have spoken to us about, are we disrupting or polluting the genetics of the wild trout? And some of the, in fact, actually the two pictures you see there are tributaries to Nash Stream. Some of the research we've done up there strongly suggests that no, the hatchery trout brook trout are not spawning with the wild trout. And there's all kinds of interesting reasons about that. But then in another place, we had some really great students at Plymouth State University that did some research in the Beebe River watershed, genetic research, and they found that, in fact, the hatchery trout are spawning with the wild trout. So it's site specific. And we're not sure exactly why it seemed to get totally different results in two different areas. We have some suspicions and we're doing some more research on it. But one of the things that we recently decided to do was to no longer stock the smaller streams in the state. A lot of it was because we know that's where the fish are really, the trout are really spawning. And we made a conscious decision, let's not put other hatchery trout right there because they might spawn with the wild trout. And we're concerned again with the alteration over time of the genetics of a population and potentially making them not as fit for survival.
Great.
Oh.
Well, Oh, go
Before I
ahead.
finish, I just want to make this point and make it clear. So we're already revising our stocking, how we stock. We're still going to stock, for example, the Lamprey River, which is too warm for brook trout anyway. But we stock the trout there so that people can go and catch them, take them home and eat them. But we are actively rethinking and looking at ways to reduce any potential impacts of our stocking on the genetics and also competition with wild trout. I mean, it's a big change that's going on right now.
Has there ever been any thought in stocking from a DNA perspective, trout that are more closely related to our trout, or at least stocking trout that might survive better in our rivers and streams?
Yes, we capitalized on our good relationship with Maine Inland Fisheries and Wildlife. They did that in Maine. In fact, when I lived in down East Maine for a number of years, that was when they just started it. What Maine did is they went out, they sent some people out like me, their staff, and they caught wild brook trout in various streams, one of which was only about 5 miles from where we lived. I thought that was neat. And they brought those into the hatchery and bred those and raised them up and then bred them and stuff. And they were using them to stock for exactly the reason you just brought up. Those fish don't do as well in the hatchery. They cost more. They're more susceptible, I think, to diseases and stuff like that when they're in, all tight quarters. And so I think Maine has stopped doing that for the most part. And I hope I'm not misspeaking on that, but I think that's the case. We did use some of their Kennebago strain, which is a slower growing, but gets larger and lives longer strain. We were specifically stocking those remote ponds with them, but we've gone back to our original hatchery strain on that again. It's just so expensive to raise so few of those wild strains.
Great. If there aren't any other questions, then I would love to say thanks a lot for all the great information. It's really interesting to see what's going to happen with the population and climate change of brook trout. And, from a recreational perspective, I definitely am curious to see where all of that leads, and hope some positive things come in the future for sure. But thank everybody for coming as well. Thanks to John. Thanks to everybody for joining us for the virtual science pub tonight. And thank SLA and the Squam Lake Conservation Society too for being partners in this. And I'll post in the chat if anyone's curious about the podcast that is there. You can check that out on our website. And we also have another virtual science pub coming out next month, which is on butterflies. And that will be with Heidi Holman from Fish and Game as well. So thank you all for coming. Enjoy the rest of the week and the upcoming weekend. We have some fine weather. So get out and enjoy. Thanks.
Thank you for spending an hour with me.
Thank you very
Thanks,
much.
Jeremy.
Yeah, thank you.